Now we're going to start the Module 2A review video. This one is key for your success on the final because this is foundational in our factoring skills. So questions A through F and number 4 are all going to be factoring. So depending on how many terms we have, we will determine what method of factoring we need to use. Question A, that is X method. So on X method, I put that A times C on top. So I'm looking for factors that multiply to be 15, add to be -8. Those numbers are -5 and -3. So my final answer is X minus 5, X minus 3. I do not need to divide and slide because our A value is just 1. And more importantly, I don't need to solve this one. These are all factoring problems. Factoring means I finish at parentheses. If I added an equal sign, which you'll notice question number 5 has, that would mean we were solving. Question B, we have a big GCF we need to take out first. They all have a 3 in common. Left over is x squared plus 8x. We add that x in there plus 8x minus 20. Again, this is X method. -20 goes on top. 8 goes on the bottom. The factors that work are 10 and -2. Notice that 3 is not an A value. I do not need to divide and slide on this one. So when I write my final answer, I bring that 3 down, x plus 10, x minus 2. Again, that is my final answer. Question C is 2 terms. As soon as we see something that's 2 terms, where everything is a perfect square separated by a minus sign, that is difference of 2 squares. So I need to have 2 sets of parentheses, one with a plus, the other with a minus. I then take the square root of each term. The square root of 9x squared is 3x. That goes first. The square root of 4 is 2. That goes second. And that, again, is my final answer. In question D, we have something that is 4 terms. On stuff that's 4 terms, we do grouping, which means we split it down the middle first. On the left side, they have a 2x squared in common. Left over is x minus 3. If I do my job correctly, x minus 3 should be left over on the right side as well. So I'm going to drop that minus sign and take out a 3, which does leave me with x minus 3. So then my final answer, when I put it all together, is 2x squared minus 3 and x minus 3. So whatever came out as my GCFs are my first factor, and then whatever matched is my second. In question E, it is going to turn into difference of squares, but not before I take out a big GCF, which is 3. Left over is 25x squared minus 1, where I then need to have my 2 sets of parentheses, one with a plus, the other with a minus. And just so I don't forget, I'm going to bring that 3 down as well. Again, 25x squared, 1 and 1 are perfect squares separated by a minus sign. So I'm going to take the square root of each. Square root of 25x squared is 5x. And square root of 1 is 1. So the concept of taking out a big GCF is something that you have to check for every single problem that you do, no matter what type of factoring you're doing. Letter F, there is no big GCF, so I'm going to go ahead and go right into X method, but don't forget we have to multiply our A and our C values together to give us -18. So I'm looking for 2 numbers that multiply to be -18 that add to be 17. Those numbers are 18 and -1. Now our A value is 2, so I need to divide everything by 2. Let me figure that out there. Need to divide everything by 2 in order to get my factors. So now as I go through, I'm going to divide everything by 2 like we said and see if they simplify. And I lost my cursor. Give me just a second here. All right, there we go. So I'm going to divide by that 2, and then we're going to see if they reduce. This one on the right does not reduce, so my first factor is going to be 2x minus 1. On the left side, and again, we go bottoms up. On the left side, they had a 2 in common, so this one will reduce to 9 over 1. I can put my variables in the denominator as I read them bottoms up. So my second factor is going to be x plus 9. And that gives me my final answer. Now that we are on to question 5, all of our problems have equal signs. So those indicate that we're solving using one of the methods that are listed above. So if we're solving by factoring or quadratic formula, we need to get everything equal to 0. So in question A, I'm going to subtract 35 on both sides so that I'm left with x squared. Let's make that a plus 2x instead of p. Minus 35 equals 0. So now I'm going to factor it, where negative 35 would be on top, 2 would be on the bottom. So my factors would be 7 and negative 5. I don't need to divide and slide. This should be x plus 7, x minus 5 equals 0. When I solve, it means that I'm setting my factors equal to 0 and solving, okay? Which in this case means that I'm just flipping signs. So x equals negative 7 and positive 5. So now that we have equal signs, our answer should be x equals something. For question B, we're going to do the same thing. This one is also 3 terms, so I'm going to try to do x method on it. Negative 12 would be on top because our a times our c, with negative 11 on the bottom. So those two factors that will work are 1 and negative 12. Again, I have to divide and slide by that 3 in front. For negative 1, positive 1 and negative 12, I got to add that 1 in there. So we're going to see if they reduce. This one reduces to negative 4 over 1. I'm going to put a variable on it. Again, let's make this an x instead. So my factors are 3x plus 1 and x minus 4 equals 0. So we're going to set them equal to 0. This one's the easy one. X equals 4. The other one is going to take 2 steps. So I'm going to subtract 1 and then divide by 3. So that one takes 2 steps. So negative 1 over 3. But either way, I get the 2 solutions that I need. For problem C, this one only has 1 x squared in there. So that's an indicator that we are solving by square roots. So to do that, I'm going to get x squared by itself by subtracting 7. 91 minus 7 gives me 84. I divide by 7. So x squared is going to give me 12. Okay, so my goal here is to get x by itself. So that means I'm going to take the square root of both sides, and I'm going to be left with plus or minus whatever the square root of 12 is. It's not a perfect square, so I have to break it down. I'm going to end up where the 2's come out, a 3 stays behind. It's a positive 12, so I do not need an I. Positive and negative 2 root 3. Question D is very similar because we have those parentheses that are squared. So if we have parentheses squared, our job is more or less the same. We're trying to isolate that, get that part by itself, then we can square root both sides. To clear out this fraction, I'm going to multiply by 3 on both sides so that we're left with x plus 1 squared equals 27. So then I can take the square root of both sides, where x plus 1 will be equal to plus or minus the square root of 27. I'm going to go ahead and break that down now into 9 and 3, where 9 can be 3 and 3. So I have a 3 that comes out, a 3 that stays behind. The problem here is that x is not by itself yet. So to do that, I have to subtract 1. But that just means I add it in front. I cannot combine it with anything with the radical. So negative 1 plus or minus 3 root 3. Letter E looks like we would be able to try to do factoring, but there wouldn't be any factors that exist. I could try to do 7 on top, 1 on the bottom, but again, nothing would work here. So if nothing works, we have to do quadratic formula, which is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a, where a is 7, b is 1, and c is 1. So negative 1 plus or minus square root of b squared minus 4ac all over 2a. So when we do this, I'm going to start by typing in the stuff in the radical, but not including the radical. So just 1 squared minus 4ac, which gives me negative 27. So negative 1 plus or minus root negative 27 over 14. I'm going to break 27 into its factors, 9 and 3, where 9 can be 3 and 3. The difference on this one is that it was a negative 27, so I need to bring out an I as well. So negative 1 plus or minus 3i root 3 over 14. The last thing I would want to do is check if there's something that negative 1, 3, and 14 have in common. I never check for anything underneath the radical, but in this case, they have nothing in common. That is my answer. And finally, on the last one, I'm thinking this one might be quadratic formula too. We do have to check though. The thing that I do notice though is there's a big GCF that we can take out first. All three of these numbers have 2 in common. So when I take that out, I have 3x squared minus 2x minus 4 equals 0. So if I try to do x method, negative 12 would go on top, negative 2 on the bottom. There would be no factors that work, so unfortunately we have to do quadratic formula again. So we see that quadratic formula over there on the left, so we're going to plug it into. So this 2 in front we can ignore. That's not going to give us a solution, but a is 3, c is negative 2, b is negative 2, and C is negative 4. You will have gotten the same answer if you directly plug this in without taking out the GCF, but it makes our numbers a little bit easier. So x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So again, I'm going to simplify underneath the radical. That's going to give me a positive 52. So 2 plus or minus root 52 over 6. 52 we can break down into 26 and 2, 26 into 13 and 2. So I have a pair of 2's that can come out with a 13 that stays behind. So 2 plus or minus 2 root 13 over 6. This one, the 2, 2, and 6 all have something in common. So my final answer is 1 plus or minus root 13 over 3. All three of those values were divisible by 2. Question 6 asks us to complete each complex operation below. So we have 3 different complex operations that we're given. The first one, they have that minus sign in front. That's an indicator that we're doing subtraction. So I have this invisible 1 here that I will be distributing through as a negative 1. So we can't just drop the parentheses. This is not a multiplication problem. This is just combining like terms after we distribute that negative 1. So we're going to add 4 plus 5i minus 1 plus 6i. So the numbers go with the numbers. That gives me 3. I's go with i's. That gives me 11i. That one, just combining like terms. Question B, we had a little bit of practice with. But if you are simplifying a radical, break it down into 18 and 10, or whatever works for you, 2 and 5, 9 and 2, 3 and 3. So I have a pair of 3's that match, a pair of 2's that match, and a 5 that stays behind. So if I bring out more than one thing, I bring them both, 3 and 2. It was a negative number, so I need that I. The root 5 stays. From here, we'll just multiply them together. Anything that I bring out can get multiplied. So 6i, root 5 is my answer. On letter C, though, letter C is multiplication because I have no operation in between. If those parentheses are written right next to each other, that indicates multiplication. So I'm going to double distribute here, or sometimes call it FOIL. So I'm going to start with that part. That gives me negative 14 plus 21i. Then I'm going to go over to the second half and do the same thing. So minus 4i plus 6i squared. As we simplify, the middles will combine to give me 17i. I squared, it's one of our properties. that equals -1. So if I take this +6 times -1, that number is really a -6, which I will then combine with the -14 to give me -20 plus 17i. Question 7 asks us to describe the number and type of solutions for each quadratic below. That means that we're going to use b squared minus 4ac to determine our answers. That is called the discriminant. Based on what we get, that's how we interpret our results. So it's part of the quadratic formula. So a is -4, b is 5, c is -1. So 5 squared minus 4 times a times c. If you're doing it by hand, 5 squared is 25, minus 16 will give me a +9. It doesn't matter what the number is, just that it's positive. A positive number will give us 2 real solutions, which is our answer to that problem. B is the same thing, where A is 1, B is 4, and C is 4. When I go to plug it in, I have 4 squared minus 4 times 1 times 4, which gives me 16, minus 16, which gives me 0. You could just directly plug this into your calculator as well. But either way, if we get 0, that is 1 real solution. The other possibility would be 2 imaginary solutions, which is what we get if there were if we ended up with a negative number as our discriminant.